Hi all, welcome to Clear and Concise. Let's have a look at this question. Here a matrix is given. We need to find the eigenvalues of given matrix. For that we know determinant of A minus lambda I equals to 0 yields a characteristic equation whose roots are eigenvalues. Here A is the given matrix, lambda is the eigenvalue, I is the identity matrix. Now let's substitute the given matrix and identity matrix. That yields determinant of A is minus 5, 2, 2 minus 2 minus lambda times 1 0 0 1, determinant is equals to 0. That yields determinant of minus 5 2 2 minus 2 minus lambda 1s are lambda 0s are 0, again lambda times 0 0, lambda times 1 lambda, that is equals to 0. Now subtracting these two matrices yields minus 5 minus lambda. Just subtract corresponding terms. 2 minus 0 is 2, again 2 minus 0, that is equals to 2, again minus 2 minus lambda, that is equals to 0. For 2 by 2 matrix we know det of A is equals to AD minus BC, that results in minus 5 minus lambda times minus 2 minus lambda minus 2 times 2, that is equals to 0. Now just simplify this equation. That yields minus 5 times minus 2 minus lambda minus lambda times minus 2 minus lambda minus 4 equals to 0. That yields minus 5 times minus 2 is plus 10, minus 5 minus lambda times is plus 5 lambda, again minus lambda times minus 2 is plus 2 lambda, minus minus plus lambda times lambda is lambda square, minus 4 equals to 0. We will have lambda square plus 7 lambda plus 6 equals to 0. So this can be written as lambda square plus lambda plus 6 lambda plus 6 equals to 0. Taking lambda common, lambda times lambda plus 1. Here if we take out 6 as common, plus 6 times lambda plus 1, that is equals to 0. So we will have lambda plus 1 equals to 0 and lambda plus 6 equals to 0. That yields lambda equals to minus 1 comma minus 6. So the correct answer is option A, minus 6 minus 1. We can use a simple trick to find the eigenvalues of this matrix that I'll discuss now. By using properties of eigenvalues, trace of the given matrix A is equals to sum of eigenvalues. Sum of eigenvalues is equals to trace of the given matrix, and determinant of given matrix is equals to product of eigenvalues. Product of eigenvalues. So now let's take for option A, sum is product, sum and product. Let's find for each option. Sum for option A is minus 6 minus 1, that is equals to minus 7. Product is minus 6 times minus 1, that is equals to 6. For option B it is 6 minus 1, that is equals to 5. Product is 6 times minus 1, that is equals to minus 6. For option C minus 6 plus 1, that is equals to minus 5. Product is minus 6 again. For option D, sum is 6 plus 1, that is equals to 7. Product is again 6. Now let's find the trace of the matrix. Trace of A is equals to sum of diagonal elements, that is this is our diagonal. So sum of diagonal elements is minus 5 plus minus 2, that is equals to minus 7. Then find the determinant of given matrix, that is equals to AD minus BC. So minus 5 times minus 2, this is AD, minus BC is 2 times 2, that is equals to 10 minus 4, which is 6. So trace is minus 7, determinant is 6. Here we need to find a match, that is sum is minus 7 and product should be 6. So option A is the correct answer. Option A is the correct answer. This is the simple shortcut to find the eigenvalues of given matrix.